Hello, everyone. Today we will be discussing Chapter 6 Descriptive Statistics. Descriptive statistics are used to describe or summarize data, which can be either a representation of the entire population or a sample of a population. An example of descriptive statistic is the average GPA for students in a specific grade. Before we start, we need to learn more about variables. What is a variable in statistics? A variable is defined as the number of characteristics that can be measured and that varies over a sample of population. For example, age, income, gender, and political affiliation are variables that can be measured. Variables can be divided into two categories, the categorical and continuous. The categorical is a variable that has a limited number of possible values that fall into categories, based on some quantitative property or qualitative range, such as 1 to 5, 6 to 10, and so on. Whereas the continuous is often described as a variable that can take on an infinite or large number of possible values, such as temperature, age, and weight. Within these two categories, there are different scale of measures. The categorical has nominal and ordinal scale of measures. The nominal is a measure with two or more categories that do not have a nature order, such as gender, race, and first language. The ordinal is a measure with two or more categories that can be ranked or ordered, but the distance between categories can't be measured precisely, such as military rank and educational level. The continuous category has the interval and ratio scale measures. The interval scale of measure is a measure that has numeric value and the magnitude between intervals is the same, such as temperature in Fahrenheit and date. The ratio scale of measure is a measure that is the same as an interval measure, but it also has true zero value, such as income and weight. Types of descriptive statistics: frequency tables and modes, median and percentiles, mean, variance, standard deviation, and coefficient of variation, cross tabulation. Frequency tables and modes are used for all type of variables. The frequency tables can be used with all variables regardless of their scale of measurement. Researchers often begin with generating frequency tables to examine the distribution of each variable. In Table 1, the example on the left side of the screen, we can see frequency table that shows the actual number of frequency and percentage of each type of college in the dataset. The cumulative column adds up to the percentage from the percent column. On the right side of the screen, in Table 2, we can see an example of a frequency table from multiple variables. We can notice that the total number of college reporting their policy is 1,789 compared with 2,264 in the first table that lists the type of the sector. We can notice that there are some missing data. When a variable has a missing data, it is important to identify patterns and reasons behind the missing data. If we wanted to include the number of missing values in the table, we could add missing at the end of the command that generates a table to add the missing data. Modes is the most common value in a variable. It can be used for both categorical and continuous variables. In some cases, there may not be mode if all values appear once or the same number of times. In other cases, you could have bimodal or multimodal distribution whereby there is more than one mode. The easiest way to find mode is to look at a frequency table and see which value appears most frequently. Although the mode is sometimes called a measure of central tendency, the mode could be at the low or high end of the distribution of a variable. The median is found by ranking a variable from its lowest to its highest value, and then identifying the observation or number that falls exactly in the middle. If there is an odd number of observation for the variable, then there will be one number that presents the middle value. If there is an even number of observations, then you would use the average of two middle values. Percentiles. A percentile is a value below which a percentage of the data fall within a variable. For example, if you score 85 in SAT, then 85% of all students who took the test earned a lower score than you. In this table, you can see that the first two columns show the percentile of the value for each percentile. For example, the 90th percentile is 9,976, indicating that 90% of all colleges have fewer than 9,976 students. The median, or the 50th percentile, is 1,538.5. The third column shows the four smallest number in the variable and the four largest. Finally, the last column shows the number of observation and the mean along with other descriptive statistics that we will cover later. The calculation of the mean or average is expressed mathematically where x is the value of each individual observation of the variable and n is the number of observations or values of the variable. Although an average is commonly used in statistics, it is often useful to calculate both mean and median. The median is particularly useful when there are outliers or extreme values in a variable. Income is a classic example, since a billionaire in the dataset will skew the average to a higher value than is typically for a household. By calculating the median or middle value instead, it offers a much better picture of income for a typical household in the middle of the income range. To show the difference in the mean and the median, this table shows the age of five respondents, and they are 20, 25, 35, 40, and 95. Although the four of the five respondents are 40 years or younger, the mean indicates that the average age of the person in the example is 43. The median, on the other hand, gives a better idea of someone in the middle of the group. Variance and standard deviation. Variance is a measure of how spread out the value of one variable are from their mean. The standard deviation is simply the square root of the variance. The table shows how the variance and standard deviation work. As we can see, the first variable is made of three observations that are identical: 50, 50, and 50. There is no variance in these numbers, and the resulting variance and standard deviation are zero. In variable b, however, there is a large variation in the three observations, and thus a very large variance of 2500 and a standard deviation of 50. Coefficient of variation. The coefficient of variation, or CV, is calculated as the standard deviation divided by the absolute value of the mean and multiplied by 100. It tells us how much variation there is in a variable relative to its mean. The table shows the standard deviation for an age variable measured both in years and in total months. We can see that the standard deviation will differ. The standard deviation for age in month is exactly 12 times the standard deviation of the age in years, but the CVs shows that they are the exact same variation relatively to their mean. Cross tabulation is used for categorical variables measured on a nominal or ordinal scale, also referred to as crosstab or contingency table. A cross tabulation allows you to combine two categorical variables to learn more about their relationship or their joint distribution. For example, cross tabulation is used to show the percentage of colleges that require or recommend the SAT score by each type of college. We can see in the table the number on top represents the actual number of colleges in that category, and the number below is the percentage. In this example, we can see on the first two rows that 104 private for profit colleges neither recommend nor require SAT or ACT, which represents 56.22% of all private for profit colleges. In this example, we have included the command row to add up the percentage across the rows to 100%. Sampling weights. Sample weights is used to estimate the total in the population from a sample data. Sampling weights compensate for the distortions introduced by sampling, allowing us to calculate means and percentages from the sample that are unbiased estimates of the population statistics. Sample weights can be used with many commands in Stata that generate tables. For example, let's suppose that the population is 10% urban and 90% rural, but the sample is split 50-50 between urban and rural households. This means that the urban households are overrepresented in the sample. So any statistics calculated from the sample will be disproportionately affected by the urban household. In addition to tables with data, charts or graphs are often useful to display information. In this section, we will be discussing the most common types of graphs that can be used to display the information. Bar graphs is used to represent data in bars. We can generate bar graphs of the average tuition rate by the type of university using stata command graph bar mean. With a box plot, in addition to comparing means, we can see the dispersion of a variable. We can use the static command graphbox to create a box plot. Looking at the graph, we can see the line inside the shaded box represents the median value. The upper and lower borders of the box represent the upper and lower quartiles. Histograms. A histogram is a better choice for a continuous variable with numerous values. For example, college tuitions, which is a continuous variable, can be illustrated in a histogram. We can use the stata command hist to generate histogram diagram on stata. Looking at the graph, we can see the frequency of the vertical axis shows the number of colleges. Then looking at the height of the bar, we can see how many colleges fall into each range. Pie charts. A pie chart is useful for categorical variables with limited number of categories where only one category can be selected by the respondent. For example, using the type of college from the previous example, we can make a pie chart.